Welcome back. In this lecture, we're going to be discussing errors and exception handling. Errors are bound to happen in your code. Nobody's perfect, and errors are definitely going to arise, especially when someone else ends up using your code in an unexpected way. We can use error handling in an attempt to plan for possible errors that may arise in our code in the future. For example, maybe in some part of your code you try to open up a file. So later on, someone else is using your code, and the user may try to actually write to the file when it was actually only opened with the mode R for reading. Currently, if there's any sort of error inside our programs, the entire script's going to stop and we get back some sort of error statement. We can actually use error handling to let the script continue with the other code and report the error. So even if there's an error, the code will report the error and continue on. Now there's three keywords for this entire process of exception handling, and it's the try, except, and finally keywords. And these are all going to have a block of code associated with them. So under the try block of code, that's the block of code that's going to be attempted, and this may or may not lead to an error. So once you try the actual try block of code, if there is an error, you have the except block. And this is a block of code that will execute in case there's any error inside of that try block. Then you have a finally block of code, which is a final block of code which is always executed whether or not there's an exception or error occurring. Let's jump to the notebook and see some examples of how to use these blocks. Okay, let's start off by actually viewing an example of some error that may occur. Let's imagine that we have a very simple function, some add function, takes in n1, n2, and then what it does, it just prints out the sum of them, n1 plus n2. You may be thinking, no problems here, I'm just going to say add 10 and 20, and you get back 30. But let's imagine you have the following situation. You have some variable, number 1, and you set that equal to 10. Then you have a bunch of code, and later on, to get the second number, you ask for it as an input. And let's say number 2 is equal to the input of please provide a number. So it asks us, please provide a number, we say 20, and then what we end up doing is we say, well, let me call that add function again on number 1 and number 2. Hopefully you realize that this is already going to give you an error, because recall that when you call the input function, 20 here is actually a string. So when I run this, it says, hey, you have a type error. So notice here that there's an actual specific exception that Python's trying to tell you about, type error. And it says unsupported operation, type S, for plus, integer, and string. It's basically telling you, hey, I can't add an integer and a string together. I can add two integers together, or I can concatenate two strings together, but I can't work with both these data types. And this is an example of the type of error you may get while running your code. And unfortunately, let's say I wanted to have a print statement. So let's say something happened. And I run this print statement is never actually going to occur. What's going to happen is I get an error, and that's the end of my script. Doesn't matter if I have hundreds of lines past this block of code, I will still get this type error, and nothing else after it is going to get executed. The idea behind the try and except and finally statements is that even if an error happens, we're going to try to do that block of code, and even if there's an error, we can continue with some more code. So how will we actually do this? Well, we have the try keyword, colon, and then we have the block of code. So this is the code that you want to try. So you want to attempt this code. However, it may have an error. So here I'm going to say result is equal to 10 plus 10. Whoops. There we go. So we know this is not going to actually induce an error. And then what I'm going to do here is I'm going to have my except block of code. So my except block of code is what I want to have happen if there is an error. And this is really common when you're building out larger libraries that other people are going to use. You can have except blocks, so you can print out a more specific message to the user. So maybe you can say, hey, it looks like you aren't adding correctly. So I'm going to run this, and notice we actually don't induce an error. Instead, I can call result here with no problem as 20, which makes sense because 10 plus 10 has no problems. Let's now actually create that error. I'm going to try to add the integer 10 to the string 10 here. Now when I run this, it says, hey, it looks like you aren't adding correctly. Now notice what happened here. The rest of the block of code was still able to execute with the except statement. My whole program wasn't shut down just because I had some sort of error like before. Instead, I tried this block of code and then I said except. And in general here, I can say except if there's any type of error, do this code right here. Now let's imagine that I want a block of code to execute if there is no exception. I could do something like this. I can say else print result, and above that I can say print add went well. So right now when I run this, it just says, hey, it looks like you aren't coding correctly. So this is known as a try except else statement. And what we have here is the block of code we're going to try, and then we have two options. If there is an error in that try block, we run the except code. Else, if there is no error there, we run this else code. So let's fix this and have it not produce an error anymore. We run this. We try this block of code. Since it was successful, we don't execute this except block of code. Instead, we jump straight to else and we say add went well, and we have 20. Okay, so let's try except else, and we can now actually use the finally keyword to have a block of code always executing, regardless if there's an error. So to show this, I'm going to build off of an example where we actually try to write some files. So let's explore this concept of try, except, and finally by working on a new example. And in this example, we're going to try to open up a file. So we'll have some test file, and we're going to start by opening it in W mode. That's write mode, which allows us to either open the file and write to it, or create the file if it doesn't already exist. And then I will say f.write, and I'm going to write a test line to this file. And then I will say except, and here I can either say except : and that's going to accept for any errors, but there's actually many types of errors I can specifically accept for. For example, I can try to only accept for this type error. So what happens is, notice above we had this specific type error. What I could do is say, hey, only if there's a type error, print out there was a type error. Then I could try another error that's actually associated with opening and writing files. And if you go to the documentation, you can come to errors and exceptions, and this explains syntax errors and exceptions in general, but you'll notice there's a link here to built-in exceptions, which jumps you to section 5 here of the documentation, and this is actually a list of all the different types of exceptions and errors that may happen. So if you keep calling down, there's an assertion error, there's end of file error, import errors, index errors. Some of these you may have seen before, a lot of them we haven't seen. There's OS errors, recursion errors, overflows, all different kinds of errors that you can specifically try to catch. So in our case, the error that's going to occur when you're opening and writing to files that you don't have permissions to is an OS error. And we're going to print, hey, you have an OS error. You can also say IO error, depending on what version of Python you have. And then we're going to add in a finally block. And this finally block is always going to execute no matter what. So say I always run. I'm going to run this right now. And right now we just get back I always run. So what's actually happening here? Well, we open up the test file, we call write on it. So that all works, meaning I don't have this except block running, and I don't have this except block running. So then I just say finally, I print I always run. Now let's actually induce an error by opening it with R. So that's read-only permission. So we should get an error on this line when we try to write to the file. Now we shouldn't get a type error because that's not actually the error we're getting. Instead, we should get an OS error because that's the error that's related to trying to write to a file that you only have read permissions for. So if I run this, I get back, hey, you have an OS error. And unlike last time where we had this except else where only one of these blocks was going to run, with the finally statement, the except block will run and then the finally block will run. And this is how you can line up a bunch of excepts to have specific things print for specific errors. What you could do is, let's say you have type error here and you didn't want to memorize all the other types. If you just say except at the end of this, this is going to be all other exceptions. So all other exceptions. And I rerun this again, and it says all other exceptions because it didn't detect the type error or any other errors that we defined. So if you just say except colon, you'll print out that error. Okay, so keep in mind, as you're beginning in Python, you probably won't memorize all the error types, and most likely your blocks of code are just going to look like this: try, except, and finally. So just to reiterate, the try block of code is the block of code you're going to try to attempt. The except block of code is going to occur when there is an error in your try statement. And then you have the option of putting a finally block here that will always run whether or not there's an error. Or you can have an else block of code that's only going to execute when there's not an error. Okay, so let's focus on this one more time here. Right now, there is going to be no error because I will say W there. If I run this, I get back I always run. So there's no error, finally block still runs. We induce an error. We say all other exceptions because I'm just saying in generally except here. It does whatever this block of code says. Finally, it does this block of code. So this finally block, regardless if there's an error, it's always going to run. So let's finish off our discussion here by showing you how to use the try except finally blocks inside of a function that tries to get a specific type of input from a user. So what we're going to do here is the following. We'll say def ask for int. So what this function does is it's going to attempt to ask the user for an integer. So we'll say the following. Try to result is equal to integer of the input. Please provide number. And then if we get an error here, I'm going to say except, and I'm going to print out, whoops, that is not a number. And then I'll say finally print end of try except finally. So I run this and we're going to iterate on this function in just a little bit, but I'm going to call this function right now, do shift enter. It asks me to please provide a number. Let's give it one, 20. And I just get end of try except finally. It makes sense that whoops, that is not a number didn't print because we were successfully able to cast or transform 20 into an integer. But what happens if I run this cell again and now I provide a word? Now I know I definitely can't transform the string's word into an integer. So when I run this, it says, whoops, that is not a number, and we get an end of try except finally. So let's see how we can now use a while loop to continually be doing this try block of code and then except if there's an error there. Okay, so let's see if we can adjust this function so that instead of just ending after you provide the wrong word, we're going to put it inside of a while loop that keeps going over and over again until you actually have a block of code with no exception. So what I'm going to do is say while true, and you should always be careful when doing while true because it basically means you need to use a break statement somewhere to break out of this while loop. I'm going to indent all of this, so highlight it all, hit tab here, and I'll say while true, get this result as the input. Then I say except, whoops, that is not a number, and then I'm going to say continue, just to make this a little more readable as far as the logic of what's happening. Now let's say there is not a error. Then I'm going to say else, so you can actually combine else with finally here. So we're going to try this block of code. If there's an error, I'm going to say, whoops, that's not a number, continue on. Else, meaning there is no exception. That means the user did provide an integer, so I will say, yes, thank you. And now I need to break out of this while loop. So I will say here, break, which remember the break statement goes up to its enclosing loop, either while loop or for loop, and then ends it. So it will end this while true loop. Then finally, we'll say end of try except finally. Okay, so we just put these 4 blocks of code inside our while true, and we're going to break once we say yes, thank you, And we'll have a finally statement that says print end of try except finally. And we can just make it very clear that print I will always run at the end. So regardless if there's an error or not, this finally block of code is always going to run. So we're going to run this, ask for an integer. Let's provide it a correct integer. We'll say 20. Hit enter. It says, yes, thank you, end of try except finally, I will always run at the end. Let's provide it a string. We'll say q, hit enter, and it says, whoops, that is not a number. End of try except finally, I will always run at the end. Except we have while true here, and this break hasn't actually executed yet. So we have another chance to provide it a number. We'll say q, it says whoops again, and you can keep providing it over and over the wrong things, and it's going to keep asking you for input until you finally provide something that can actually be cast as an integer. You say 90, and it says, yes, thank you, end of try except finally, I will always run at the end. So note what's happening here. We're saying while true, try this block of code. If there's an exception, do something, and then continue. Else, meaning there is no exception, you can print some sort of statement and then break. And typically, you're only going to want to break out of this while true when there is no exception. Then finally, if for some reason you wanted something to continue, so a good thing here could be like, I'm going to ask you again, new line. So that's more a realistic example of why you would say finally. So if I run this again, it'll say, please provide a number. We give it the wrong answer. It says, whoops, that is not a number. I'm going to ask you again. Please provide number. And then you can provide it the correct number, and it says, yes, thank you. Now, unfortunately, it's going to say, I'm going to ask you again. So that's why a lot of times people don't like to mix up else and finally statements, but there's the option for you in case you want it. What you could do instead is just get rid of that finally statement and run your code like this, and you'll say, please provide number, q, whoops, that is not a number, and you can keep doing this over and over again until you actually provide the number and it says, yes, thank you. It's up to you whether you want to mix else and finally blocks, but you can if you want to. All right, that's the basics of try, except, else. Coming up next, we're going to give you an assignment to test your new skills on this. We'll see you there. Welcome back, everyone. Now that we understand how to work with errors and exceptions handling, let's get some practice with a quick homework set of 3 problems. Let's go over the notebook so you can attempt it yourself, and in the very next lecture, we'll go over the solutions. Okay, so you can find this notebook under Errors and Exception Handling. It's the second notebook, Errors and Exceptions Homework. The very next notebook is the solutions. So there's 3 problems in here. The first one is to handle the exception thrown by the code below by using try and except blocks. So notice here we're saying for I in this list of strings, I'm trying to square the actual strings. That doesn't really make sense. So try to use a try and except block to handle this somehow. That's a pretty open statement, so you can just print something like an error occurred and then maybe have something else happen. Basically, just don't have this type error pop up. Problem 2 is to handle the exception thrown by the code below by using try and except blocks as well, and then use a finally block to print all done. So right now we have a 0 division error, so we're trying to say 5 divided by 0. Go ahead and catch this exception and then have a finally block execute. Then problem 3 is kind of similar to what we discussed towards the end of the previous lecture, and it's to write a function that asks for an integer and prints the square of it. I want you to use a while loop with a try except else block to account for incorrect inputs. Okay, best of luck, and we're going to go over the solutions in the very next lecture. Welcome back, everyone. In this lecture, we're going to go now over the solutions for the errors and exceptions homework problems. Let's open up Jupyter Notebook and get started. Okay, taking a look at the first problem, it was to handle the exception thrown by the code here below. So let's copy this and put it in a new cell. If I just run this by itself, we get that type error because we're trying to square a string, which doesn't really make sense. So what we need to do is put this whole block of code inside of a try block. And this is where indentation is really going to matter, because now we need to indent everything in order for alignment. So we have this try block right here, and then we can make an except call. And it's up to you whether you want to say except and catch that specific type error, and then print out type error, or whatever you want. So if I run this, it says type error, watch out. Or if you don't want to catch this specific error, just any error, you don't actually need to say that. You can just say except, and you get the same thing. In this case, it wouldn't be a type error. We could just say something like general error, watch out. Main idea being that you need to put that piece of code inside that try block, have an except line up with it, and then say something. Let's move on to problem 2. This was to handle the exception thrown by the code below using try and except blocks, then finally block to print all done. I'm going to copy this, put it back here, and if I just run this, let's confirm that we get an error. Looks like we're getting a 0 division error. So let's put this all inside of a try block. We will say try and indent all of this into the try block. You could also just highlight it all and then hit tab. Then I'm going to say except, and again I can either say except 0 division error or just except by itself. We're going to print out error, and then finally we'll print out all done. Hopefully this was pretty straightforward. So we say error, all done, and then the last one, probably the most complicated of them, was to write a function that asks for an integer and prints out the square of it. Use a while loop with a try except else block to account for the incorrect inputs. So we're going to copy this. We did something very similar in the lecture. So what are we going to do here is say while true, and it's up to you if you want to say while true or while some condition. So I'm going to say while true, try to say n is equal to the integer input of enter a number. Now if we have some sort of exception, and we're going to assume that the exception occurs when you try to transform that into an integer, we'll print out please try again. And then let's print out a new line, and we'll say continue. Now else, that means there's no exception. What we can do is say break. Optionally, you can have the finally in there, but remember the finally is going to occur every time. So let's run this and make sure this works. So we're going to say ask, shift enter to run that, enter a number. Let's say we enter 10, and it looks like we forgot to actually print out the squared, which is what it was asking us. If we come back here, we're going to say thank you, your number squared is. So let's do that. And this is going to be outside of that while statement. So once this entire while loop is done running, we should have n ready to go. So we're going to print n to the power of 2. And we can say above that, print your number squared is. There we go. Okay, so now let's try this again so we actually get the results. We'll ask this again, enter a number. We'll say 10, enter, number squared is 100. So that's working. Let's now try to do something wrong. So we'll say A, and it says please try again. We'll say WE, please try again. Let's enter 2 now, and the number squared is 4. Okay, so that's how you can use a while true. So notice that while true is dependent on this break keyword. What you could do instead is say while something like waiting, and we can set waiting to be equal to true. So this is saying like we're waiting for a correct response. You can call this variable whatever you want. So I'm waiting for a correct response. I'm going to try this. I'm going to have the exception. Else, if there's no exception, then I can set waiting equal to false. I'm no longer waiting for the correct response. So that's the same thing, except we're not using a break statement. So we can try this again, make sure that tactic also works. Let's enter the wrong thing. Please try again, enter the right thing, and it works for. Okay, so that's it for errors and exception handling. If you have any questions, feel free to post to the Q&A forums. I'll see you at the next lecture. Welcome back, everyone. Now that we understand how to handle errors and exceptions in Python with the try, except, and finally blocks of code, let's move on to discussing unit testing. As you begin to expand to larger multi-file projects, or you begin to work with a team that's bigger than just yourself, it becomes really important to have tests in place. This way, as you or your teammates make changes or update your code, you can run your test files to make sure previous code still runs as expected. There are several testing tools, and we're going to focus on 2. There's other ones mentioned in the notebook that goes along with this lecture. but we're going to focus on Pylint, and this is a library that in general looks at your code and reports back possible issues. Maybe you have styling issues, or maybe you have some invalid code, and it will report back issues with your code. Then we have the unit test library. This is a built-in library in Python that's going to allow you to test your own programs and then check if you're getting the desired outputs. We're going to begin by showing you how to use Pylint to check your code for possible errors in styling. And if you're wondering what I mean by styling, Python has a set of style convention rules known as PEP8, and we'll show you those in the documentation. And then afterwards, we're going to explore how to test our code with the built-in unit test library. For this lecture, we're going to be creating .py scripts in Sublime because that's a more realistic example of how you'll actually be using these programs. You can still use the associated notebook for code. It has a bunch of write file magic Jupyter commands to create the .py scripts. So if you're really intent on sticking with Jupyter, the Jupyter notebook does work for this lecture, but in the actual filming of this, we're going to use the text editor because it's a little more realistic. Okay, let's get started. Okay, the first thing we need to do is install the Pylint library. So let's go ahead and do that at our command line. So if you're at your command line or your terminal, if you're on Mac OS or Linux, all you need to do is straight into your command line, don't call Python before this, is just say pip install Pylint. Hit enter, so that's Pylint. Right now, I already have it ready to go because it came with my distribution of Anaconda. That may be the same case for you, but make sure you run this line just to check that you have it already. Once you have that ready to go, let's go back to our text editor. Alright, so here I am at the text editor, and I'm going to create a very simple .py file. So let me say File, Save, and I'm going to save this to my desktop, and I will save this as simple1.py, which is a very simple file. You can save it wherever you want, as long as you're able to call it at the command line. If you're unfamiliar with how to actually run scripts like this, make sure you go back and visit the lecture at the beginning of the course called Running Python Code. Okay, so I will say a is equal to 1, and notice I have syntax highlighting. That means it's registered as a .py file. Then I will say b is equal to 2. Notice my lower cases here. Then I will say print a, and then I will say print, and I'm going to make a mistake here on purpose. I'm going to say print capital B. Even Sublime Text is telling me, hey, I think you mean lowercase, but we're going to ignore that for now. So it's just a very simple script, but there's definitely a mistake in it right here. So as you can imagine, with 4 lines, it's pretty easy to catch this mistake, but if you have a script of hundreds of lines, it's going to be much harder. So do Control S or Command S to save this, and once you have it saved, come to your command line. And then what we're going to do here is say Pylint. So notice I'm not saying Python. I will say Pylint, and then say simple1.py. Remember that you have to be at the same location as your .py script, and you can view the command line lecture to get an idea of how to move around at your command line. But let's hit enter here and see what happens. Okay, so we actually get back a bit of a report here. And what Pylint does is it issues what is essentially an automated report grading your code. So if we scroll all the way back up here, it says no config file found using default configuration, so you can set more advanced configurations. And we have final new line missing, so we have some issues, and these are styling issues. We have an invalid constant name, but most importantly, notice here, this is an actual error, so it has an E here. And these are the ones you really want to watch out for, an undefined variable B. So later on, it gives you statistics as far as whether you're using functions, method, classes. So if for some reason you want to figure out, well, how many classes do I have? How many functions do I have in this code? And are they documented? Do they have a stylized name that's inappropriate? For example, maybe you accidentally capitalized a function. So this would be giving you statistics on that. Then it gives us raw metrics, such as how much code are there, how many doc strings are there, comments, how much is empty. So if you're working with other people and you demand, hey, every other line should have a comment on it, you could use this to quickly check. Now, whether or not you need that many comments is up to you, but hopefully you can see in more of a management position how these sort of reports would be really helpful, either to give to your manager or to receive as a manager. Then we have duplication, so how many lines have been duplicated. Right now we have 0 because it's such a simple file. Then we see messages by category, so if there's errors, warnings, so here we're actually getting an error. So notice it ran the code and it got an error, and then we have some more information about messages. And these are what kind of messages actually rise up when you run that Pylint report. And here we're getting a bunch of messages. We have undefined variables, there's missing doc strings, because it's just a simple file with a huge mistake in it. So global evaluation, at the very end, it's going to evaluate your code, and here we're getting a horrible evaluation, which is negative 12.5 out of 10. So perfect score is 10 out of 10, and here we're doing absolutely horribly with negative 12.5. So Pylint, it's listing some styling issues. It would like to see an extra new line at the end. Modules and function definitions should have descriptive doc strings. Single characters are also a poor choice for variable names, so it's kind of complaining about that too. And most importantly, out of all of this, it found that error in the program. So let's try to clean this all up and see what kind of score we can get. And I should note here, it's pretty difficult to try to aim for a perfect 10 out of 10. So don't be stressed if you're not getting a 10 out of 10 on your own code. Sometimes to get something 10 out of 10, it has to be very machine readable instead of human readable. And you always want to balance that if someone else views your code, they're going to be able to read it easily. However, we can definitely make some improvements here. So let's see what we can. Okay, so back at the script, let's see if we can improve this whole thing. Often when you're dealing with a .py script, you're going to want to have a multi-line comment at the top just so other developers can come in and understand what's going on. So here we're just going to say a very simple script. So that should help us score some points with Pylint. And then we're actually going to create a function definition. So we'll say myfunc, won't take any parameters. And again, we should give our functions a doc string. I'm going to zoom out just a little bit here so we can see the whole picture. And here we're going to say a simple function. And then let's actually create two new variable names. First is equal to 1 and second is equal to 2, because usually you don't want to use just a single letter as a variable name. And then we'll print out first. And then what we're going to do is we're going to print out second here. And at the end of this, we're going to actually execute the my function. So we'll say myfunc, open close parentheses, execute at the bottom. So notice here the indentation. I'm going to save this, and let's run this again in Pylint and see if we were able to improve our score. Again, most likely we won't get a 10 out of 10, but we should see a big jump from negative 12. All right, I'm back here at my desktop. First, let's just make sure that our script actually runs. We'll call simple, or Python, simple1.py. You should be able to tab autocomplete that. And we get back 1 and 2. Looks like it's running. Let's now check the score. We'll say Pylint simple1.py, hit enter. And now we get back 0 out of 10. So it looks like we still have some issues, but we're no longer getting negative 12.5 out of 10. All right, now you may be looking at this and saying that it looks like a lot of our problems are with mixed indentation. And if you scroll up here, you'll realize that it's telling you about all these warnings. It's found indentation with tabs instead of spaces. Due to styling issues, especially with different text editors, so let's say your colleague opens this up in PyCharm and you're opening it up in Sublime, someone else is opening it up in Atom, you typically, when you're working for other people, want to use spaces instead of tabs. Now again, this is very much just a styling choice. The code will still run fine. As we just saw, they had no problem issuing that code, but Pylint is going to complain about this issue. And you can check the documentation and say, don't worry about this particular warning. Usually you do want to have it warn about mixed indentation, but you don't want to have it warn about pure tabs or pure spaces. So in order to fix this issue, you can go back to your script. Let's do that now. So here I am at my function, and you'll notice that when I was defining my function, all I did was hit enter, and then that basically auto-tabbed for me. So if I hit delete or backspace right now, it will go back one tab. So to fix that, what we can do is make sure everything is defined as spaces. So delete this right here, and then do 1, 2, 3, 4 spaces. And if we do that for every line, I've actually already done that for you. I've actually already done that myself on this script. We've done that for you in the Jupyter Notebook as well. But now you should be able to improve on that. So I'm going to save this. And if you ever have a doubt, are these tabs or spaces, in Sublime Text Editor, you should be able to highlight. And here, it probably won't show up on your screencast, but I can see 4 very faint dots indicating each space. And if you just have a tab, you won't see that. So you'll have to see that on your own screen. But again, it's just highlighting this, and you can see the spaces. And if you have just enter, you'll end up seeing a tab here, just one straight line. So Pylint will complain when you mix those together. So let's save this and go back to our command line. And now I'm going to rerun Pylint on my simple1.py script now that it only has white spaces. I'll hit enter. And it looks like now we're getting much better. We're getting 8.33 over our previous run. And you may got 6.67 after fixing that. I've run this a few times trying to deal with that white space issue. And this is most likely probably about as best as we're going to get without having to put in a bunch of extra comments and code. Okay, that's really all we need to know about Pylint for our use cases. And in general, when you're just coding by yourself, you won't be using something like this that often. This is really more for when you're working with other people or you're working with really large programs and you have kind of strict methods for yourself to make sure everything is up to some sort of style convention. Again, it's not really useful for just a rating to come back to a single user because you just saw the entire bit of code. Okay, so that's Pylint. Coming up next, we're going to learn about unit test, which allows you to write your own test programs. Notice here that we're basically running a bunch of tests. It'd be nice if we could write our own. We'll see you at the next lecture. Welcome back, everyone. In this lecture, we're actually going to go over the unit test library. So unit test allows you to write your own test program, and the goal is to send a specific set of data to your program, analyze the returned results, and then see if it actually gives you the expected result. So let's actually create two scripts here. One is going to be a simple script that capitalizes text, and then the other script is going to be the actual test script for this. And you're going to need to review object-oriented programming to understand how to use unit tests because you do build out a test class. Let's get started. Okay, here I am at Sublime Text Editor. I'm going to create two scripts. We'll say new file, save as, and on my desktop, I will save the first one as cap.py. So this is the script that's actually going to capitalize given text. And then the next script will say file, new file, file, save as, and I'm going to save this. And technically you can call your test script whatever you want, but we will call this one test underscore cap.py. Save that, and those are both saved right now in the same location. So our cap.py file will be very simple. It'll just have a single function inside of it, and this function takes in some text, and then what it does, it's going to return text dot, and we're going to capitalize the text. So if you don't recall, capitalize method on a string just capitalizes the first single letter. It doesn't actually uppercase everything. So you can check that yourself quickly at the command line, but that's what the capitalize method does. We expect text to be some sort of string. So basically here, we're going to input a string, output decapitalize string. And by capitalize, we just mean capitalize that first letter. I'm going to save this. So cancel, save that, go to test underscore cap, and this is where we actually use the unit test. So when writing test functions, it's best to go from simple to complex, as each function is going to be run in order. So you usually want to test simple things and then later on test the more complicated things. The first thing you need to do is import unit test, and then you're going to need to import any of the files we want. And because these files are both saved at the desktop location, I'm going to say import cap. So that actually imports my other .py script, this cap.py. So I've imported unit test. That's a built-in function. And whoops, let's make sure I spelled that right. It has two T's, so watch out for that. It's unit test, two words in order. Import cap, that's the cap file we just created. And then we're going to create a class. And we'll call this class test cap. And we're going to inherit the test case class that comes with unit test. So we say unit test dot test case. So if this syntax is strange to you, you can review the inheritance lectures in object-oriented programming. But here we're just going to have a list of methods, and these methods are basically going to be run when we test this actual script. So we'll say def test one word self, and this is just going to be set text equal to the simple word Python, and the result is going to be, we'll say cap, and we'll call the cap text function. So what I'm doing here is I'm importing cap, and then from cap.py, I'm importing this cap text function. So I'm saying cap.cap text function, and I will pass in the text, so that's lowercase Python, And I would expect my result to be equal to the following. We say self dot, and we call assert equal. We pass in result, and then we pass in Python with a capital P. And this is the general structure of a test. And when you look at it, it's actually really quite simple. All you do is you create your class to be called at the end. You inherit from unittest.testCase, and then you have a function to be called. In this case, we call it test1, and usually you number them like test1, test2, or you maybe have names that refer to what they're actually doing. So here we could have test one word, and then the next one could be testing multiple words. So here we have text is equal to Python, and then you call whatever functions you want to test off your script. So that way, if someone comes in and they start editing cap.py, and you want to make sure that this function always returns the same thing, you now have this test that will assert that. So you get the result of something passed into that function, and then you say self.assert equal, and you're saying, I need that when this lowercase python gets passed into the captext function, that it always returns back the capitalized P version of Python. And then we can add in another test. So we can say DEF, and we can call this test something different. You can either number them, or you can define them as far as what they're testing. So maybe we want to test multiple words. We'll say self, and then we'll add in some text here and set that equal to, let's have it be 2 words, Monty Python. And it's basically the same thing here. We say result. So copy and paste that. So I want my result to be passing in Monty Python to text, and then I will say self.assert equal. Let's copy that line as well onto the new line, except in this case, when you call capitalize on this string, what it should do is capitalize the first letter of each of these words. So I should expect to see Monty Python. And at the end of all this, we can say if, and you underscore underscore, name is equal to main. We will call the main function here, unittest.main. So save this, and let's actually now run our test cap. All right, so what we're going to do here is actually run our test code. We'll say Python test underscore cap, and you can auto tab complete that. We'll hit enter, and right now it looks like we're actually getting a failure. So you get this failure report, which is kind of nice. It says fail, test multiple words. It says Monty Python. Notice here how the P is being lowercase, does not equal Monty Python. So now we're scratching our heads thinking, well, what's the issue? Is it my test or is it my actual file? And that actually depends on the situation, but typically you're going to say, hey, I need to adjust my main script so that I make sure my testing works. And a lot of times in larger companies, you'll have someone in the QA department, quality assurance, actually writing these tests to make sure that your scripts work as they expect them to. And if we think about this, the actual issue is, as we previously mentioned, capitalize, all it does is it capitalizes the very first letter of a string. That means that if we take a look at Monty Python, and you may have noticed it as I was writing, that this is actually not going to happen when we call capitalize. And there's actually a different method for this. If I want both these letters to be capitalized, then what I need to do is instead of calling capitalized, there's actually a method called title. And that will then capitalize every single word instead of just the first letter of the string. So now let's save those changes using title and see if we pass this test. So we'll come back to the command line. And now what I'm going to do is run the same thing as I did before, Python test underscore cap. We hit enter and it says ran 2 tests and everything okay. That means you passed all your tests. Okay, that's basically all you need to know about unit testing. So let's go back and do a very quick overview, but the actual idea is very simple. So you have your scripts, and this could be lots of scripts, it could be a single script, and you call functions or classes, whatever you want. And then inside of your testing script, what you're going to have is you're going to import unit test, import any of the scripts you've been working on, create a class for testing. You're going to inherit from unit test case, and then you're going to have methods to test for any situations you can think of. So you'll set whatever variables you need, and then at the end of the day, somehow you're going to call functions or classes, passing in something, you get a result, and then you just assert equal. So you say, hey, is the result I'm getting from my script the expected result? And that's all you have to do. So just be wary of this self.assert equal statement. Notice how it's casting self so that it's actually calling it from that test case inheritance. All right, that's it for talking about unit tests. It's actually quite straightforward, hopefully. If you have any questions, feel free to post the Q&A forums, but definitely take a look at the documentation for unit test. There's a lot more that it can do, but a lot of times, especially as you're just starting out, all you really need to do is create these simple assert equal statements in your class. Thanks, and we'll see you at the next lecture.